Okay, I thought maybe we could all benefit from a quick review of factoring, just basic factoring a trinomial. Factoring is just undoing the multiplication. So remember the FOIL method, first, outer, inner, and then last. It's really important for you to understand how things are multiplied, because if you understand how they're multiplied, that's first, outer, inner, last, sorry, then you know how to undo it or factor it. Okay, just goofing off here a little bit. Let's get rid of that dude. Okay, so remember that the first times the first gives you the guy in the front. The last times the last gives you the guy in the back. And the outers and the inners combine in the middle. So let's try this guy on for size here. The first times the first gives me the guy in the front. The last times the last gives me the guy in the back. In this case, negative, because my signs were opposite, 3 times 2. Now the outers gives me a negative 2x. And the inners will be positive 3x. But remember that you always combine those like terms in the middle, right? So combining those terms gives me a trinomial, meaning that I have 3 terms. In this case, I end up with x squared plus x minus 6. Now, what we have to learn from foiling things out and always combining the guys in the middle is we have to figure out a way to pull the middle guy apart so that we can go backwards and unfoil, okay? In this case, the leading coefficient was 1. So what we have to do is figure out the coefficients of the last in such a way, these are factors of the last guy, in such a way as to combine them to be the guy in the middle. So let's do that. Okay, we're going to use the guy that we just multiplied out and pretend we don't know what the answer is. The first times the first has to be x squared, so it's x times x. The last times the last gives us a negative 6, so we need to find the factors of negative 6. But when we do the outers and the inners, they have to combine to be positive 1. So I know that I have to use the 2 and the 3. I know I'm subtracting to get 1, but the 1 is positive. So the 3 is a plus and the 2 is the minus, and boom, you're done. Okay? Because that leading coefficient was a 1, I only had x's to worry about. Let's try another. X squared minus 5x minus 24. Okay, so now the leading coefficient is 1. So I know I have 2 binomials, and the first times the first is x times x. I want to factor 24 so that I can subtract to get negative 5. So writing down all the factors of 24 here, I need to figure out a way that they combine with the opposite signs to be a negative 5 in the middle. That means I have to use the 3 and the 8, and to get a negative 5, 8 is the negative one. And because my leading coefficient was 1, I can just write those factors down. Now, you have to be very careful with your signs. Let's do a couple more examples here. If I have minus 10 in the middle and plus 24 at the end, look at these factors of 24 up here. We got to figure out a way to combine the factors of 24 to get a 10, right? A negative 10. Oh, this was a plus. Let's try it with a minus and see what happens. So in the first case, I know I have x times x. And in the second case, I have x times x. That part's easy. Now I want, in the first case, I have a plus. I want the factors of 24 that add to be negative 10. So look at this list of factors of 24. These are the two numbers that will add to be 10, but notice they have to add to be a negative 10. What does that mean? It means that both of these guys have to be minuses, right? So a -4 and a -6. Foil this out and you'll see that you get this guy. Now this guy, the only difference is this sign right here, that minus sign. Now I have to subtract the factors to get a 10, and that gives me the 2 and the 12. Notice that I'm looking for a negative 10. That means my 12 has to be minus, and my 2 has to be a plus. That gives me the last times the last is a negative number, but the outers and the inners combine to be also a negative number. So a positive 2 and a negative 12. So be very, very careful with your signs. If you had gotten the 2 and the 12 over here, oh, well, that gives me a 10 and it's negative, your last times your last wouldn't have been right. So you always foil these things back out and make sure that your answer was correct. Okay, so now we come to the situation where the first times the first is not just x times x. In this case, we have to get a 3. Well, there's only one way to factor a 3, so this one's not that bad. We've got a 3x times an x. But what about the last times the last? We could trial and error this thing by plugging in the factors of 7 here and here, and then foiling it out to see what happens in the middle. But I'm going to show you a way to figure out how to do it right from the beginning. So when we foil, I'm going to make another little dude here, then I'll erase him. When we multiply the first times the first, we get the first. When we multiply the last times the last, we get the last. But look at my outers and my inners. I'm taking one of the factors of the first and multiplying one of the factors of the last. Well, that leaves the other two factors, right? I have the other factor of the first times the other factor of the last. And the last step of foiling it out is to combine those two x terms in the middle. So what we have to do is take all of the factors of the first and all of the factors of the last, throw them together, and then factor that answer in a way that will add to be the guy in the middle, because we have this factor times this factor and the other times the other. So we're just going to put them all together in one great big pot and figure out what they were to begin with. So cleaning up my little picture here. In my case right now, I have a 3 in the front and a 7 in the back. And it's a negative. When I multiply 3 times negative 7, I get negative 21. The outers and the inners are going to be the factors of negative 21, and then we're going to combine them to get a plus 4 in the middle. So what are those factors? 1 times 21 and 3 times 7. Now, I know that we all knew it was going to be 3 times 7, but if this was a bigger number with many ways to factor it, you're always better off making an entire list of factors so that you can see every possible situation. Excuse me. So, we need the factors that combine to be positive 4, and we're subtracting those factors. If the last times the last gives me a negative, then I'm going to have 1 plus and 1 minus when I do my outers and my inners. So we're subtracting the factors that add to be positive 4 here. And because I have a plus and a minus, again, these are opposite signs, but they add to be positive. So the big one's a plus and the little one's a minus. Now hold the phone. Every problem we did before, we just took these two numbers and stuck them right here. But we have a 3. We can't just plug these values in. These values represent the outers and the inners. And we have the outers here and the inners here. Now, look at my outers. This guy right here is going to be 3 times something. And one of these guys is 3 times something. Which one is it? It's this one. So I need this to be negative 3x. What has to be in this spot right here to make that multiply out to be negative 3x? Well, obviously, I need a minus 1. And now the inners here will be the other guy, a positive 7x. So this has to be plus 7. And now you FOIL that out to make sure that you're correct. Notice that when I combine these guys, I get positive 4x in the middle. Double checking, the first times the first is 3x squared, last times the last is minus 7. My outers and my inners combine to be 4x. Let's switch it up just a little bit. What if we have 3x squared minus 4x minus 7? Same list of factors, right? But now the outers and the inners combine to be negative. So this will be the plus and this will be the minus because of that guy right there. Okay? So there's only one, there's only one way to factor a 3x squared. 3x times x. There's only one way to factor a 7 as well. But is it a 1 here and a 7 here, or a 7 here and a 1 here? And is it a plus and a minus, or a minus and a plus? 4 different ways to do this. I'm showing you the way to get it correct the first time every time. So if the factors combine to be negative, that gives me a positive 3 and a negative 7. So this has to be a plus 1 to get a positive 3, and this has to be a negative 7. That's going to give me minus 7x plus 3x. Combine those and you get minus 4x in the middle. You see how it works? So let's try another one. 4x squared. These are hard to make up, so give me a second. Minus 9x minus 9. Let's see what happens. The first thing we want to do is put 2 sets of parentheses. But wait, there's more than one way to factor a 4. There's more than one way to factor a 9. So we're going to be really careful here, and we're going to take the first times the first, that first number times the last number. We're going to factor that guy. Whoops, hold it. Sorry about that. Negative 36. We want the factors that do this process, because they're opposite signs, to give me a negative 9. So I'm going to factor this guy. 1 times 36. Divide by 2 and I get 15 and 3, 18. 3 goes into it 12 times. 4 goes into it 9 times. And 6 and 6. Okay, we're subtracting. So 6 and 6 doesn't work. 4 and 9 subtracted give me a 5. Aha, 3 and 12 give me a 9. So it's this grouping. And now which one is the plus and which one's the minus? Well, we end up with a minus in the middle So the big guy has to be negative. Now, don't just cram those guys in. We have to look at our outers and our inners. All right, so the outers and the inners are going to multiply out to be a 3 and a 12. Now, there's more than one way to factor the first and the first and the last and the last. 12 has a 4 in it. It also has a 2 in it. So I'm going to focus on this prime number here. I have to have an outer and an inner that give me a plain old 3. 3 is a factor of the last guy. So one of these guys has to be just 3. When you practice this a while, you'll get it. So one of those things has to be a plain old 3. But the last times the last, right there, is a negative 9, right? So we are going to, let me flip my pencil here. We need a 3 to get the last times the last to be a 9. Now, notice that a 3 is a factor of both of these numbers. So one of these is a 3 times a 1, and the other one has to be a 3 times a 4. Not only that, it has to be negative. So I know that because I need a 1 times a 3 and a 4 times a 3, this is factored as 4 and 1. That tells me my first times my first. Now, we've got a 12x here and a 3x here. There's my outer and inner numbers. But the 12 needs to be a negative. That means this is minus. The 3x is positive, so that's a plus. Now, that wasn't exactly simple, but once you practice this, it comes out to be easier and easier. But I'm going to show you one more. I don't want this new way to do this to be a crutch. And if you learned how to do slip and slide in high school, I want you to forget it because you're going to get it wrong, I promise. So I want you to try the method I'm about to show you, but get to where you can do it this way, okay? We're going to do all this stuff again, but we're going to not guesstimate it. We're going to actually unfoil it. Okay, this is called the AC method, where this is A, this is B, and this is C. We're going to multiply A times C. In this case, let me do it in red like I have been. 4 times negative 9 is negative 36. Now we're going to factor the A times C to get numbers that combine to be B. So 1 times 36, remember we're subtracting. 2 times 18, 3 times 12, 4 times 9, and 6 times 6. We're subtracting to get negative 9. So we have these. The 12 is a minus, the 3 is a plus. Now once we find that, our next step is going to be rewrite and replacing the b times x with the factors that you just found. So what we have here, we have 4x squared in the front, minus 9 in the back. But instead of writing minus 9x, we're going to take these numbers and plug them in here. Positive 3, hold the phone, that looks like a 13. I don't know where that mark came from. That was supposed to be a plus. Positive, look at me, making messes. Positive 3x and a negative 12x. You see how this is the same as this? I just rewrote it. And now the last step is to factor by grouping. That means because I have 4 pieces, I'm going to group these two and group these two. Do not, under any circumstances, put a parenthesis in the middle of that thing because you have a minus. If you put a parenthesis right here, you change everything after that parenthesis because of that negative. So don't do it. First, I'm going to look at the first 2 pieces and ask myself, what's a common factor? Well, they both have x's. There's no number factor, but I can pull out an x. When I factor out an x, I'm left with 4x, a plus sign, and a 3. Redistribute that to check your work. Now in the second grouping, these are both minuses, and by the way, that middle sign always gets factored out every time. 12 and 9 are both multiples of 3, so I pull out a minus and a 3. That's going to leave me with a plus 4x. And in the second spot, I pulled out a minus, so that's a plus. Pulled out a 3, there's another 3 left. And what I want you to see, if you did this stuff correctly, then these blobs will be exactly the same. If you made a mistake, they won't match, and you can't factor it. I'll say that again. If you made a mistake over here, these blobs won't match, and if they don't match, you can't factor it. Now, if you multiply A times C and find all the factors and nothing works to get the guy in the middle, then your polynomial doesn't factor and you just write prime and move on, okay? Now at this point, we have gone from having 4 terms to having just 2 terms. But each of these terms has a common factor. Each of them has the blob. It's exactly the same in both pieces. So I'm going to pick those blobs up, pull them out front, and then make a list of what's left. Okay? So if I pulled this blob away, don't see 4x plus 3, see parentheses. Pull out the blob. Factoring is dividing, right? So he's gone, and I'm left with an x. Pull this blob out, I'm left with minus 3. And I have factored that trinomial. Now you do this a few times, you get comfortable with this part right here, you understand how things combine to give you this, and you can go from here to here to here, skipping all of this work. However, this process does work every time. There is no need at all to do this process unless that number isn't a 1. If it is a 1, you're just going to write those 2 factors in your parentheses. Okay, practice, go to P5, it's before chapter 1. If you didn't follow this, then you need to practice that because in a pre-calculus class, you got to be able to factor just about anything, all right? So you need to go back. Here are your steps for factoring by grouping. You've got step number 1, step number 2, step number 3, and step number 4 for the AC method. Okay? Get to practicing it. It's in P5. It's a chapter before chapter 1. Get some extra factoring practice. And now we're going to start 1.6, and I'm going to do I'm going to break 1.6 up into lots of small pieces, but we're starting it right here on the next page. Okay, since we did this stuff in 1.4 where we learned that the square root of a negative is I, we can now find all of the real and complex answers when we're solving an equation. Okay? Now, the zero property rule says that if I have two, I'm going to put a little thought bubble here. If I have two things multiplying and they multiply out to be zero, then either this guy is exactly zero or this guy is exactly zero. And because we know complex numbers now, whatever the highest power of x is, that's how many answers I have to find. So this problem, even though I wrote it down wrong, this problem is going to have 4 answers. So the first step is to look for common factors. So first look for the number. I've got a 5 and a 20. That means I can factor out a 5. And then I look at my x's. Look at my, where's my pointer? Look at the powers of x. I've got 4 here and 2 here. I can always factor out the lowest power. All right? Now, if I pulled those factors out, make a list of what's left. In this case, the 5 is gone. 2 of these x's have been divided away, and I'm left with 2 more. Then I have a minus sign in the middle. And now the last bit, I factored a 5. Remember, factoring is dividing. So I divided out a 5. I'm left with a 4. I divided out an x squared, so those are gone. And I have factored this equals 0. Now, here we have to stop and think a minute. We've learned how to extract the root. So I could set each of these factors equal to 0 and solve it. I'm going to show you 2 ways to do this particular problem. I have 5x squared equals 0. So now I can divide both sides by 5. 0 cut into 5 pieces is still nothing, right? Take the square root of both sides. Whoops. Take the square root of both sides, and I'm going to get a 0. But because x was squared, it was a perfect square, I get plus 0 minus 0. Well, those are both zeros, right? Now take the second piece, isolate the x squared. When I take the square root of both sides, don't forget plus or minus, and I get a positive 2 and a negative 2. 4 answers. Now, because this factor was a perfect square, I got what's called a repeated root. And by the way, having something equal to 0 and finding all the x's that make that true, we're looking for zeros. We're looking for roots. These are lots of ways to say the same thing. We're finding solutions. Later on, we'll call them x-intercepts. All right, but there's lots of other ways to name this answer as well. But you'll see that the book calls them zeros and roots most often. Okay, and remember, the highest power tells you how many you need, and if you have a factor that's with an exponent, you're going to have a repeated root that many times. Okay, let's look at this again, and I'm going to show you another way to get to the answer here. We had 5x squared times x squared minus 4 equals 0. Now, I've been teaching this class a long time, and you guys always forget the plus or minus. So, one way to avoid making that mistake, look at this guy right here. You need to remember all of your special factoring. 5x squared is done, but this guy can be factored. He's two perfect squares, x squared minus 2 squared, and I can factor that to be x times x, 2 times 2, a plus and a minus, and that's because there was no x term in the middle. The outers and the inners subtracted away. And if this is, remember, okay, another blue thought bubble here. Watch out for the thought bubbles. A squared minus b squared. If you have perfect squares and you're subtracting, you get conjugate factors, right? We talked about that a little bit. What about cubes? A cubed plus b cubed. You're going to need to remember this. A binomial times a trinomial. Are you ready? A and b, whatever the numbers were before they were cubed. And in the second piece, look, a times what gives me a cubed? Let me make this big for a second. A times something gives me a cubed. Well, a squared, right? And b cube is b times what? B squared. And then we have to remember that in the middle, I have an a times a b. And I also want to remember that my signs are SOAP. Same, opposite, always plus. Same, opposite, always plus. So in this problem, I started with a plus. So this guy is the same. The next guy is the opposite of that, so a minus. And the last guy is always plus. So knowing that, I can do a cubed minus b cubed. I'm going to put a binomial and a trinomial. I've got the numbers before they were cubed. This guy's an a squared. This is a times b. This is b squared. My signs are the same as what I started with, so a minus. The opposite of that, and the last is always plus. So now you know how to factor the difference of squares and the sum and difference of cubes. So let's get back to what we were doing over here. We had x squared minus 4. Both of those are perfect squares. So we had x plus 2x minus 2. And the zero property tells me that I can set each of these factors equal to 0. Notice that 5 is touching everything, right? 5 is a factor, but 5 can never be 0. It's a constant. So what I'm doing is I'm setting x squared equal to 0, x plus 2 equals 0, x minus 2 equals 0. I get the square root of 0, but that was multiplicity 2, so there's 2 of them. We'll talk about that more in chapter 3. When I have x plus 2 equals 0, I'm going to subtract the 2. When I have x minus 2, I'm going to add the 2. There's your plus or minus 2. And you can get that without making the mistake. Some of you can't see what I'm doing. There we go. I'm going to get that without making the mistake of forgetting the plus or minus because I factored it first. Now, also, remember this stuff, okay? Memorize it. And again, go back to P5 and practice if you need to. One more example from your book. 9y cubed plus 8 equals 4y plus 18y squared. I'm not going to do this to you, okay? We're used to seeing things in descending powers. So I'm going to rewrite 9y cubed, and then the 18y squared I'm going to pull over to the other side by subtracting it. The 4y I'm going to pull over by subtracting it. The 8 is already on the left, positive. Now it equals 0. So I can factor and set each factor equal to 0. I've got 4 pieces, so I group 2 and 2. And in the first grouping, I have a common 9y squared. When I factor that out, I'm left with y minus 2. In the middle, I have a minus. I always factor out that sign. A 4 and an 8 have a common factor of 4. When I pull out the minus and the 4, I'm left with the y. And when I pull a minus from here, I'm left with a minus. 4 from here, I'm left with a 2. Now I went from 4 terms to 2 terms. This term and this term. What's the common factor in each of those terms? The blob is the same. Pull it out. What's left? 9y squared minus 4. But wait, there's more. These two guys are both perfect squares, so I'm going to keep factoring to avoid making mistakes. 2 sets of parentheses. 3y times 3y, 2 times a 2, a plus and a minus. Set each set of parentheses equal to 0. I get y equals positive 2 because I'm adding that, right? I shouldn't write over myself here. Dang it. There we go. Now, set this guy equal to 0. You're going to subtract 2, so you get a negative. Then you're going to divide the 3. Negative 2 thirds. The last piece, you're going to add the 2 and divide by the 3. And you get, boom, your answers. Okay, for this bit, I want you to practice the P5. It's in the prerequisite chapter. Read it, do the examples if you struggle with factoring. But we are in 1.6. You're going to have 2 more videos from this chapter, section. But for now, I want you to practice 1 through 9 odd.